Welcome to Mod 3 on inequalities. Right now, pause the video, make sure you have your notebook and your writing utensil out ready to take notes. If you need help getting a notebook, you need to let your teacher know today. Note taking is super important. Your brain learns better when you slow down enough to write things down. It's also going to be helpful for you to have these notes in front of you when you take your quizzes and work on your practice problems on ALEKS. We're going to go through quite a few things on inequalities today. We're going to be working on some translating. We're going to identify solutions to an inequality. We're going to work on several real-world situations. You're going to graph inequalities and you're going to solve inequalities. I hope you're going to find that solving inequalities is not much different than solving a multi-step equation. We're first going to talk about translating. So in a new section of your notebook, would you please put translating a sentence into an inequality? That's your new heading. So no more crocodile mouth. You need to learn the correct terms. You want to make a list in your notebook of code words that indicate inequalities. So let's make sure we know what the less than sign looks like. It is the one that points to the left. You can remember that because left sounds like less than. It could also be less than or equal to. So you would say something like 2 is less than 4. 0 is less than or equal to 5. Greater than faces the other way. The arrow points to the right. It can either be greater than or equal to. So for example, 6 is greater than 2. 5 is greater than or equal to -2. Make sure you have these code words written down, and then I want you to make another list off to the right-hand side of your notebook for code words, because every time I circle one and mention it, you're going to want to add it to this list today. So if I ask you to write an inequality for the following statement, x is less than or equal to, well, you shouldn't have new code words. We've got that right here. X is less than or equal to 4. You pause the video and try this one on your own. You should have noticed that it says is greater than or equal to b, so you should have used the greater than or equal to sign and then the b. So 9 is greater than or equal to b. The product, if you don't know the word product, you're going to write that underneath your code words. Product means to multiply. The product of W and 8, so 8W, is less than or equal to, no more crocodile mouth, less than or equal to -21. You pause the video and I want you to try this one down here on your own. That's actually a typo on my part. You should have noticed that it's exactly the same thing as the one we just did. The product of 8 and W is less than or equal to -21. Sorry about that. Let's do this one. The difference of W and 2 is at least. Okay, at least does not mean less than just because it starts with an L. If I need you to be at least 16 to drive, you need to be 16 or older. So that's a greater than or equal to. Difference means to subtract. At least means greater than or equal to. So the difference of W and 2 is at least -18. You pause the video and try this one on your own. Difference, you should have known, meant subtract. So the difference of y and 4 is less than -26. Good job. All right, let's try 2 more. The difference of twice a number and 2 is at most 30. So difference means minus. Twice means 2 times something. A number, we're going to use x. All right, at most. So let's think about this in terms of a real life situation. This summer, we're supposed to gather in groups of at most 10. Well, that means less than or equal to 10. So in this case, it's going to be less than or equal to 30. So the difference of twice a number and 2. The difference of twice a number and 2 is at most, which means less than or equal to, add that to your code words if you didn't know it, 30. You pause the video and try this one on your own. Twice means 2 times something. Well, it's 2 times the difference of a number and 2. Well, I need to group those together. The difference of a number and 2 is at least, well, if at least is less than or equal to, if at most is less than or equal to, at least is greater than or equal to. Make sure you have that written down before we move on. All right, identifying solutions. We've got a new topic, so you're going to want to write this new topic at the top or at the top of your next section and underline it. You don't need a new page every time. It says for each value of y, determine whether it is a solution to y is less than or equal to 7. So you need to first make sure you know what that sign is in order to figure these out. That's a less than or equal to. We're replacing y with these numbers. So I'm replacing y with 2. Is 2 less than or equal to 7? Yes, it is. Let's try it with 5. Is 5 less than or equal to 7? Yes, it is. Is 11 less than or equal to 7? No, it's not. Is 9 less than or equal to 7? No, it's not. You pause the video and try this one on your own. You should have looked up that this means greater than or equal to, so we're replacing W with these numbers. So is 10 greater than or equal to 8? Yes, it is. Is 12 greater than or equal to 8? Yes, it is. Is 7 greater than or equal to 8? It is not, so we would say no. And is 4 greater than or equal to 8? Definitely not. Make sure you have those written down before we move on. All right, real life situations. Don't forget, we're adding to our keywords, our code words. So we're going to write an inequality to represent the situations below. So I'm going to do this first one with you, and you're going to do the second one on your own. The distance to the nearest exit door is no more than. So no more than is a code word. If it's no more than 100 feet, that means 100 feet is the biggest. So it must be less than or equal to 100, and so we would use D to represent the distance. To ride a roller coaster, a visitor must be taller than. There's another code word, taller than. That means we want it to be greater than or equal to 54. The height must be greater than or equal to 54. You pause the video and try these two on your own. Well, same code words here, no more than, but this time the distance to the door is less than or equal to 200. To qualify for the championship, a runner must complete the race in at most, all right? At most, let's think about what that means. That means it could be 45 or 44 or 43, so it's less than or equal to 45. And they want us to use T for the runner. Good job. Make sure you have these code words written down before we move on. You don't have to write all these sentences as long as you're writing down the code words. All right, let's move on. Graphing an inequality on the number line. So you should create yourself a new section for a new topic. We need to use shading to indicate inequalities on the number line. If I was, for example, going to graph x equals 3 on a number line, I would just find 3 on the number line and I would put a dot there. But now we're talking about numbers maybe that are smaller than 3 or bigger than 3, and so we would use shading. For example, if I wanted to graph that x is less than or equal to 3, I would shade to the left of 3 because that's where the numbers are smaller. We also want to be able to indicate a difference between using the equal to sign and not using the equal to sign. I use an open circle when it's less than or greater than. I used an open circle when it's less than or equal to or greater than or equal to. Notice I closed this in because it's less than or equal to. I shade to the left when it's less than or equal to. I shade to the right when it's greater than or equal to. The arrows point in the direction that you want to shade if your variable is on the left. We want to graph the inequality below on the number line. So I want to graph where b is greater than or equal to -5. So if it said b is equal to -5, I would find my number line. I would put a dot to indicate -5. But I want the stuff that's greater than or equal to. Also check out your arrow. It's telling you to shade to the right where the arrows match. And so we would shade all of this in. You pause the video and try this one on your own. All right, this time it's a greater than. So I don't want to include -2. I want to go right up to -2 and stop. And so I show that using an open circle. And it's still greater than, which means it's pointing to the right. So I would shade to the right here. Nice job. All right, let's try some with less thans. We're going to graph the inequality below on the number line. We're still under the same topic, so no need to make a new section in your notebook. We've got our number line here. We're trying to graph -9. And I want to shade where it's less than or equal to -9. Notice the arrow points to the left for less than, and so we shade to the left. You pause the video and try this one on your own. You should have put an open circle this time, where B is 3, because we use an open circle when it's less than or greater than, and you should have shaded to the right, where the numbers are larger than 3. The arrows match on the sides that you want to shade to. All right, one-step inequalities. We solve inequalities in the same way that we solve equations. If I was trying to solve x plus 2 equals 4, I would subtract 2 from each side, and so x would equal 2. I do the same thing for an inequality. If I was trying to solve x plus 2 is less than 4, I would subtract 2 from each side, and so x should be less than 2. So let's try these. I have -16 plus w is greater than or equal to -6. There's two sides. If you want to draw a line down to help you remember that, you can. You want to find a way to remove the 16 by canceling it out. Well, the opposite of a negative is positive. -16 and +16 will make 0, and that isolates w. You bring down the greater than or equal to sign. -6 plus 16 is 10, and so your answer is w is greater than or equal to 10. You pause the video and try this one on your own. Welcome back. You should have noticed that there's two sides. We're trying to isolate w, so we subtract 6 on each side, and so w is greater than 6. Same topic. We're still, if you've started a new section for one-step inequalities, would you do that now? I think I forgot to tell you on the last screen. You want to be careful about flipping sides. Some of you are really bothered by the fact that you have the y on the right-hand side. This is the one time I'm going to let you think about crocodile mouths. The crocodile mouth is eating the y minus 13. I can flip this over if I want. I can switch sides. I could do that if I had an equal to sign. But if I'm going to switch sides, I need to flip my inequality as well. Remember, the crocodile mouth was eating the y minus 13, so it still needs to be eating the y minus 13. If I switch sides of my inequality, I need to flip over my inequality itself. Now we're going to add 13 to each side, and so y is greater than or equal to -14 plus 13 is 1. You pause the video and try this one on your own. If you did it without flipping sides, you subtract 5 from each side, and so 20 is less than x, and then you would have to flip it over so that x is greater than 20. Remember, the crocodile mouth is eating the x, the crocodile mouth is still eating the x. If you flipped it over at the beginning, you should have rewritten it as x plus 5 is greater than 25, because the crocodile mouth is eating the x plus 5, and so we still need the crocodile mouth to be eating the x plus 5. Minus 5 from each side, and so x is greater than 20. So either answer is fine, they're the same, you just depends on how you want to solve. Same heading, you don't need a new heading in your notebook. If I want to solve this one, I'm going to divide both sides by 8. And so I get v is less than or equal to 7. You pause the video and try this one on your own. Don't forget about switching sides if you want to. If you want to go ahead and switch sides, you can. It becomes y over 5. The crocodile mouth needs to continue eating the 12, so it has to flip over. The opposite of divide is multiply, so we multiply both sides by 5. Those cancel because 5 divided by 5 is 1, and 12 times 5 becomes 60. So y is less than 60 there. All right, you pause the video and try these two on your own. Welcome back. You should have multiplied both sides by 5 here, so u is greater than or equal to 40. For this one, you should have divided both sides by 7, so y is less than 10. All right, what happens if we need to multiply or divide by a negative? Let's examine a couple of equations and inequalities that we know are true. Because of the properties of inequalities, I should be able to do the same operation on both sides of an inequality, and the inequality should still be true. That works the same for equations. So for example, I know that 4 equals 4. I should be able to divide both of these sides by 4 and have this still be true. 4 divided by 4 is 1, 4 divided by 4 is 1, 1 equals 1. That works whether I divide by a positive or a negative 4. 4 divided by -4 is -1. 4 divided by -4 is -1, so that's still true. It should still work the same way with an inequality. If I divide both sides by 4, 4 is less than 8, that's true. Divide both sides by 4, I find out that 1 is less than 2, and that's still true. But what if we need to divide by a negative? -4 divided by -4 is +1. bring down my less than. 8 divided by -4 is -2. Is 1 less than -2? No, it is not. We have a problem whenever we need to multiply or divide both sides by a negative. That creates an issue where our statement now becomes untrue. When we multiply or divide both sides of an inequality by a negative, it changes the truth of the inequality. To fix this, we need to flip the inequality. So let's go back to our previous screen. If I had kept the 1 and the -2 in the same place, but remembered that when I divide both sides by a negative, I have to flip my less than to a greater than, now 1 is greater than -2, and that is true. So to fix this, anytime we multiply or divide both sides by a negative, we need to flip our inequality. I'm going to go ahead and change sides on this at the beginning. The crocodile mouth is eating the -2u, and so now I have my variable on the left. In order to get the negative away from -2 away from the u, I need to divide both sides by -2. Right here is where I divided both sides by a negative, which tells me I need to change my greater than sign to a less than sign. And so the correct answer is that u is less than -6. But for one like this, just because there's a negative doesn't mean I need to flip. Did I divide both sides by a negative? No, I did not. I don't need to flip that one. It's not necessary. You pause the video. I'll do this first one with you, and then you can do the second one on your own. We have y divided by -2 is less than or equal to 10. The opposite of divide is to multiply. Well, right there, I multiplied both sides by a negative. That means I need to change my less than or equal to a greater than or equal to fix the truth of the inequality. So y is greater than or equal to -20. For this one, u divided by -4 is less than or equal to 10. You try this one on your own. You should have multiplied both sides by -4. The -4's cancel out. Because you did something to a negative on both sides, we multiplied on both sides, we changed the less than or equal to a greater than or equal to, and so u is greater than or equal to -40. All right, two-step inequalities. 3x minus 4 is less than or equal to -22. With the exception of needing to flip, these are exactly like a two-step equation. We add 44 to each side, so 3x is less than or equal to -18. We divide both sides by 3, and so x is less than or equal to -6. You pause the video and try this one on your own. Welcome back. You should have started by subtracting 14 from each side. So 3w is greater than or equal to 24. We divide both sides by 3. I did not divide by a -3, so there's no reason to flip. And so w is greater than or equal to 8. If we need to switch sides, we can. Just be aware of the crocodile mouth. The crocodile mouth is eating the 5w plus 16, so it's going to follow the 5w plus 16. We're going to subtract 16 from each side, so we get 5w is greater than 101 minus 16, which I believe is 85. Yep. And divide both sides by 5, which I believe is 17. Yep. And so w is greater than 17. You pause the video and try this one on your own. You should have started by flipping this over and then also flipping over the crocodile mouth. We're going to subtract 10 from each side, so 5x is greater than or equal to 30. Divide both sides by 5, and so x is greater than or equal to 6. Watch your negatives here. You want to add 8 to each side. So we have -5y is less than or equal to 10. Here we divide both sides by a negative, so we have y is greater than or equal to. I'm going to flip my less than or equal to over because I divided both sides by a -5, so y is greater than or equal to 2. By the way, we moved on to two-step inequalities, so you might want to write that as a heading somewhere near these. -6u minus 27 is greater than or equal to -15. We're going to add 27 to each side, so we get -6u is equal to 12. Oops, not equal to, greater than or equal to. And then we're going to divide both sides by -6. Think to yourself, what do we need to do when we divide both sides by a negative? Well, those cancel out. The greater than needs to change to a less than or equal to. So u is less than or equal to -2. All right, last type of the two-step inequalities. What if we have this divide on the inside? Some of you like to go ahead and multiply everything by 4. I don't necessarily need to do that first because I can see that I can just add 7 to each side. So I have x over 4 is greater than or equal to 4. Multiply both sides by 4 so that the 4's cancel out. No reason to flip, so x is greater than or equal to 16. You pause the video and try this one on your own. You should have started by adding 5 to each. So we have x over 3 is less than 3. Multiply both sides by 3 so that the 3's cancel, and x is less than 9. All right, some word problems. Don't forget to add new keywords that we find to your list of code words for inequalities. Lisa runs each lap in 4 minutes. She will run less than 28 minutes today. What are the possible number of laps that she will run? We're going to use n for the number of laps that she will run today. So we know she's going to run less than 28 minutes. We don't know the number of laps that she's going to run, but we know each one takes 4 minutes. She doesn't have to run exactly 28, which is why we're using an inequality. We're going to divide both sides by divide both sides by 4. The 4's cancel out, and so n is less than 7. All right, for this one, Dan runs each lap in 5 minutes. He will run at least 10 laps today. Well, at least means greater than or equal to, so it's greater than or equal to 10. He's got some number of minutes that he's going to run that in, and so that's going to be divided by 5 to get the number of laps that he's going to run. We need to multiply both sides by 5 to solve, so t is greater than or equal to 50 minutes. So essentially, he's going to have to run at least 50 minutes to get 10 laps in today. All right, the city is building a rectangular parking lot. As soon as I see that word rectangular, I start making myself a picture. The city wants the length of the parking lot to be 5 yards. The area of the parking lot must be more than 30 square yards. Well, remember, area is length times width, and I want that to be more than 30 square yards. I don't know the width. That's a question mark. I do know the length. So it's 5w is greater than 30. And so we would divide both sides by 5. And so w is greater than 6. So for the area of the parking lot to be 30 yards, we would need the width to be greater than 6 if the length is 5. You pause the video and try this one on your own. All right, welcome back. The school is painting its logo in the shape of a triangle in the middle of its sports field. So we've got the triangle here. The school wants the height of the triangle to be 4 feet. So there's the 4. The area of the logo must be more than, well, more than means greater than, 18 square feet. Well, remember, the area of a triangle is 1/2 times the base times the height, and we want that to be more than 18. So 1/2 times the base times the height should be more than 18. Well, I know the height, it's 1/2 times the base times 4 should be more than 18. I can combine these two pretty easily. Half of 4 is 2, so that's 2b is greater than 18. Divide both sides by 2, so I know the base of the triangle has to be greater than 9 feet. All right, don't forget to add any new keywords to your list of code words as we are doing these. Jim has a tree in his backyard. The tree grows 45 centimeters each year. Since the tree started growing, Jim has trimmed 22 centimeters off of its height. The goal for the tree's height is given by 45x minus 22 is greater than 248, where x is the number of years the tree grows. First, solve the given inequality and graph the solution on the number line below. So let's do that first. We're going to add 22 to each side. We get 45x is greater than 248 plus 22. That gives me 270. We're going to divide both sides by 45. 270 divided by 45 gives us 6. So x is greater than 6. We want to graph this. Remember, we want an open circle on the 6, and greater than means to the right. Then we're going to choose and complete the statement that best describes the solution. Well, let's think about what x stood for. X is the number of years that the tree grows to be greater than 6. So to meet the goal, the tree must be more than blank centimeters tall. Well, let's see. We know that it's got to take more than some number of years, so it can't be this one. It's got to take more than 6 years. To meet the goal, the tree must be more than blank centimeters tall. It must be more than 248 centimeters tall. So it has to be this one here. You pause the video and try this one on your own. All right, you should have started by solving the equation, subtracting 62 from each side. 3x is greater than 110 minus 62, which is 48. Divide both sides by 3, and so x is greater than 16. Let's make sure we know what x stands for. X is the number of weeks. So the number of weeks that the crew needs to work is greater than or equal to. By the way, I lost my equal to sign. So it should be greater than or equal to 16 weeks. So we're going to graph this. I want a shaded in circle on the 16, and I want a shade to the right. Well, let's talk about the goal. The goal was greater than or equal to 110. So let's narrow it down from here. Would at least or at most mean greater than or equal to? At least is greater than or equal to, so it can't be this one. So it's either at least 110 miles here or at least 110 miles here. Now let's look at our weeks. Greater than or equal to, is that at least or at most? It's at least, so it should be that one. All right, Frank wants to earn at least $34 trimming trees. We already learned that 34 means greater than or equal to. He charges $7 per hour. On your code word, I want you to write that words like per are telling you that you need slope. So that means that needs to go with our variable. Fees, that's a one-time fee. That should be your y-intercept. That means that's your constants. So it's 7x plus 8 is greater than or equal to 34. Looks like they wanted us to use t, so let's replace x with t. We're going to subtract 8 from each side, so 7t is greater than or equal to 34 minus 8, which is 26. Divide by 7 on both sides. This does not come out evenly, which is okay. So it's greater than or equal to 26 divided by 7, which is, you could just leave it as a fraction, or you could say that t is greater than or equal to 3.7. You pause the video and try this now. All right, he wants to spend less than, so you should have used your less than sign. Per, you should have noticed means slope, so t is our number of hours. And Trey has a discount coupon for $3 off, so we're subtracting 3 from each side. Now we need to solve, add 3 to each side, so 7t is less than 56. Divide both sides by 7, and so t must be less than 8. He only has less than 8 hours he can rent the boat for. All right, that was a long one today. Sorry about that. This video will be available on Haiku if you need to rewatch, and will be available on each scale for Module 3 in ALEKS. You need to log on now and do your Module 3 practice problems. Don't forget that if you need help, you can click on the explanation. It'll give you the explanation and the solution, but then we'll give you a different question, and you can also click on why if you need some extra help. Don't forget to take your quizzes. A larger part of your grade than the practice are the quizzes, so when you're done with Module 3, you need to click on Assignments. You need to do that in the upper left-hand corner of the home page, and you need to find Quiz 3 that goes with Module 3.